start out my slides with, to show you quickly, start out my slides with a dog drinking water from a garden hose. So it's the analogy of prepare for a fire hose of information, especially only in 60 minutes. To cover Istio in 60 minutes, it's a bit hard, but there's a lot to cover. So my name's Jonathan, Jonathan Johnson, and I live in about 2 hours in between both New York and Boston. We just experienced an interesting hurricane that turned into a tropical storm, and that storm knocked out most of the power and the internet as well for many of the residents here in Connecticut, including me. So I'm actually in a different. I set up my studio here, and this is a lovely facility. So you should have uninterrupted presentation for this entire time. So let's kick this off. And we'll talk about Istio. Now, if you don't know anything about Kubernetes yet, this is kind of an advanced topic on top of Kubernetes. Now, in about 12 hours, I'm going to be doing a 3-hour workshop on Kubernetes concepts with a K, another twist on the title. So the Kubernetes concepts is really about the fundamentals about learning about Kubernetes. This is an advanced, once you know about that, this is an advanced topic on top of that. However, if you don't know anything about Kubernetes, it still might be, it will be fascinating for you to see this. So what I'm going to be talking about is adding a networking layer on top of Kubernetes. Now, Kubernetes itself is a distributed system, and it handles networking, and it has all the things that you normally see within a meshing system. But it adds, the meshing system on top of Kubernetes adds this extra level of control that you can have as a developer. Now, when I'm speaking to you as a fellow developer. How do I use these tools in order to accomplish my tasks? Now, if you're a DevOps engineer, administration, networks engineer, security operations person, SRE, this is still going to make sense to you. I'm just telling you, I'm coming from an engineering standpoint, software developer. How do I get my applications running on Kubernetes? So I love talking about cloud native systems. Cloud native systems, one of the implementations of cloud native is Kubernetes. It tends to be the operating system for clusters, for distributed systems. Nowadays, that's what it's called. And it's the de facto operating system that people are using. So I love talking about all the topics around Kubernetes, this ecosystem of cloud native of Kubernetes. And Istio is a big topic, and it's a very popular topic on it. The topic right after this, I'm going to talk about Knative and serverless on Kubernetes as well. So let's dive into it. So what is a mesh? A mesh is exactly this. It's a service-to-service network that supports safe, fast, observable, routable, and reliable communications. Kubernetes, like I said, Kubernetes does that underneath, but the meshing is adding this extra level of all these features. And I'm going to take you through some of the features. At the end of this session, I'm going to walk you actually through a hands-on tutorial that shows you Istio working on top of Kubernetes. Hopefully we have enough time to cover it all. And in that one, I'm going to talk about, I'm going to show you an example of traffic management and routing, just one of the features that is inside of Istio. There's too much to show you all in one session, but what I want to give you is a survey of how this all works. It's giving you these types of features. It's also, what I tell people when they're starting to learn about Kubernetes, don't add Istio meshing or any kind of meshing on top of Kubernetes until you understand Kubernetes first. Again, it's a topic you want to go. It's going to make your life more complicated by going down the meshing route. But if you're already using Kubernetes, if you add it, you're going to see the value add once you start adding it, because it starts adding these extra features in there that are essentially missing from the infrastructure of Kubernetes itself. That's what this meshing system is adding on top of it. So Kubernetes is a tool set, as well as Istio is a tool set that is addressing essentially the 8 fallacies of distributed computing. And these are the fallacies. Basically, the fallacies are you should never rely on everything being stable all the time. And we know that as software engineers all the time. But as soon as you take an application that's running on a single server and you start breaking it up, monolith microservices, you start getting smaller services, microservices, and you start putting those on containers, and you start running those on different servers in your cluster, in your data center, that distribution means you're adding more risk because things are going to fail. Now, if you just have 10 of them, it's not going to fail that much. But based on the number of how much you scale out to distributed systems, the risk of something, one of these fallacies kicking in, increases to the point where eventually it's not if it happens, it's when it will happen. So Kubernetes handles the idea of resilience as well as Istio. And there's lots of things related to distributed. So Kubernetes is basically a distributed system. Istio is helping you manage the networking of all that distribution. There's really a lot of interesting algorithms and theories behind what gets into distributed theories behind Kubernetes. But I just want to mention a few here. I'm not going to get into all these different theories, but there's a lot of things to learn about as a software engineer to understand when you're starting to dive into distributed systems. There's some complications here, so just be aware of that. Now, the primary features of meshing are these four. I grew up in the 70s as a kid, and one of the cartoons I really enjoyed was Underdog. And every day on every episode, Underdog had a little magic pill under his ring, and he popped the pill and he turned into a superhero when things got tough for him. So I look at Istio and meshing on top of Kubernetes as that magic pill that when things get stressful, you can take that pill and become a superhero with Istio meshing. And what it adds is these four major categories: connectivity, security, ability to control what talks to what, and then observability. The key thing is when you're implementing a meshing network, all of these controls is provided in code. Infrastructure is code. But the code that's controlling the mesh is not inside your application code. It's not buried inside your containers. And this is one of the old ways of doing meshing was to bury libraries inside of your code. And that's an anti-pattern in architecture. There's tightly coupling the meshing system into your business domain. It's not a good idea. So, but when you add Istio to your networking, like I said, don't do it if you're just starting out with Kubernetes, because it's going to make your life complicated. There's a fun video called that. There's a lot of memes out there that take the movie called Hitler. The movie's called Downfall from 2004, and a lot of people have taken that movie and dubbed over some interesting things. So somebody did that for Kubernetes. And one of the lines in there was another project with 3 million lines of codes and 40 plus CRDs. Now, CRDs are these things called custom resource definitions. And they are these basically YAML manifests that are declaring to Kubernetes what to do. So when you add Istio Mesh to your Kubernetes system, it's adding about 50 plus custom resource definitions on top of Kubernetes that you have to learn. And it's difficult. So just be aware that it's this nightmare. It's more of a nightmare to learn. But I believe the cost benefit of if you're already comfortable with Kubernetes and YAMLs and manifests, then adding Istio is just going to make your life better in many ways. So the old way was to take a library approach of burying the meshing technology inside your code. The bad part of that is Kubernetes and containers is all about polyglot, lots of different languages. So it doesn't make sense to have a library for every language and every new language. What if you're doing something in Rust? Is there a library for meshing in Rust? It's difficult, and they're all going to be different, and all different versions. And it's a nightmare to maintain type of adding these libraries inside of your code. Yes, Spring Boot and things like Vertex. Add niceties within your code to do meshing type of things like correlation IDs or logging or monitoring. But sometimes a lot of that code that you're tending to do inside a Spring Boot, you could take out and you don't actually have to do it inside your code all the time, the majority of it. I'm not saying you shouldn't, I'm just saying there's a lot of meshing features that may just be able to be handled by Istio Mesh rather than you burying it inside your code. Because what do you want to do inside your code? You want to write code that's delivering value to your customers. If you're adding code inside your containers that is delivering additional features to the mesh, that's not directly to your customers. It's still helping your customers in terms of reliability and all those things, but they're not direct features that are going to your customers. So putting those things inside your containers, inside your code, it can be a nightmare to maintain all of those dependencies. So early on, one of the first popular meshing technologies that started with Kubernetes was Linkerd. It's still around and they're doing very well. There's kind of a cat and mouse going on right now between Linkerd and Conduit as well as Istio. So Linkerd early on, what they did is they had an agent, a daemon set that ran on every node in the cluster, every virtual machine in the cluster. There was a daemon on that cluster. And what it did is it took over all of the inputs and outputs, all the ingress and egresses from every node by taking over the routing table. And it captured all the network traffic going in and out of all the pods on every node. And when it did that, it could take over things like traffic management, security, logging, monitoring, observability. It could do all these nice meshing things once it took over. However, they found that when they put that container on every node of the network, it was not efficient as doing a sidecar pattern. Now, the sidecar pattern is the ability to inject a container next to every other container. So there's a pod in Kubernetes. Inside the pod runs your container, your microservice, or your business application. The sidecar injection pattern for meshing is to put a sidecar next to your main container and then have it work. And what it does is it takes over the routing table of just the pod. So a pod is basically is assigned a virtual IP, and there's a routing table for that virtual IP. So the sidecar injection of Envoy and Linkerd, through two different meshing technologies, those two sidecars take over the routing table for just that pod. So rather than doing it at the node level for all the pods on a single server, it injects a sidecar next to every microservice. Now you would think that that's less efficient because now you have not just one daemon per node, but now you have one sidecar for every pod on every node. Turns out it's actually more efficient because you're taking advantage of the distributed nature of Kubernetes. By distributing more things, you often get better performance, and that's exactly what they found with sidecar approach. So there's two competing ones. There's other competing meshing technologies. I'm going to talk about the most popular one, Istio, but I also don't want to ignore that there's others out there, and there may be others in the future coming up. So Buoyant has one called Conduit that's using the Linkerd sidecar. IBM and Lyft and Google got together and they made Istio, which is the Envoy sidecar. And it took off. So Linkerd came out first with a Conduit, but the folks at Google knew that there was a problem in Kubernetes where they already had experience with the Borg and the Omega project, knowing that there's this meshing that's missing from Kubernetes itself. So they got together, so they, meaning Google, got together with, I think it's in the next slide. No, I don't have that slide for it. So Google and IBM got together. Yes, I do. I do have another slide. So I was going to show you a slide in a second about how Google got together with Lyft as well as IBM and made Istio. But basically they did that in 2017, and when they did it, it took off in terms of popularity. Now I know GitHub stars is not a scientific way to do polling analysis, but it does give you an idea of popularity in terms of how fast Istio has taken off as a technology. So I don't want to get into the architecture of Kubernetes too deeply, but I just want to let you know that so meshing, you can do meshing without Kubernetes. In fact, you can do Istio without Kubernetes. one of the things they did early on is some of the people for Istio said, should we just make Istio just part of Kubernetes? Should we just bake it in so that when you install Kubernetes, you just get an Istio mesh with it? And a lot of us in the community, us developers, said, no, wait. We actually want to use, this is a great system, Istio. We want to use Istio for other legacy applications in our network, in our data center. And we don't want to necessarily have to depend on Kubernetes in order to get those legacy systems to be part of the mesh. So it's tuned, Istio is tuned to work with Kubernetes, but it doesn't require Kubernetes in a sense. But when you layer yourself on top of Kubernetes, you're getting a whole bunch of benefits because Kubernetes, essentially it's an operating system for your data center. You get all of these, you get a management system for all of your containers, and it's managing all your CPU, memory, and I/O for everything you're doing in your cluster. And you can do declarative manifests like this, where you say, I want an Nginx deployment. I want 3 of them. Here's the container, and here's the port. So in about 13 lines of code, you can stand up a web server in less than a minute. That's an example of a YAML file in Kubernetes if you've never seen it. These are YAML files. You make declarations to Kubernetes. There's YAML files to make declarations to the Istio mesh, and we're going to be doing that in a few minutes. All right. So, again, I don't want to get into the details of Kubernetes itself because I'm going to be doing that in about 12 hours in the Kubernetes Concepts workshop. But I just want to let you know we're standing on top of these giants. So Istio is standing on top of the giant of Kubernetes as a networking system. So the architecture of Kubernetes, I'm going to go into this architecture a little bit more deeply in my workshop. But this is the essential thing. There's worker nodes and master nodes. The worker nodes, these are all virtual machines, the nodes, master nodes and worker nodes. And on every node, there's pods. And on inside of every pod that's on every node, inside that pod is your container, your microservice, your database, whatever you may want to put inside a container. Those all run inside of pods. Now, you notice in the diagram, I have an example of a pod, 2 pods inside of a single, 2 containers inside of a single pod. And that's an example of like a sidecar injection where you can put Envoy next to your microservice to take over the networking. And we're going to, so I just wanted to pull that out as an architectural diagram. This is the way Istio is injecting Envoy into next to your pods. And it looks like this. You have a container within, 2 containers within the pod, and they communicate to each other very, very efficiently because they're in the same virtual IP. They can communicate with each other through a shared file mount via localhost, so it doesn't go through the network card. And they also can send Linux interprocess communication messages to each other, signals to each other. So there's a lot of efficiency by having 2 containers within the pod. The downfall is now you're making your pod very much larger, therefore it can't fit. It's less likely to fit into more places with the bin packing algorithm of Kubernetes. So you want to make your pods as small as possible, but you're also injecting the sidecar to make it a little bit more enhanced. That's the balance of engineering all the time. I want to do one thing, but I'm going to make a sacrifice in this other way. It's not a big sacrifice. The Envoy sidecar is written to be very efficient and small because they know that, I'm sorry, there's a bug. They know that the Envoy sidecar is going to be distributed across all of your network. So therefore it needs to be small and as fast as possible. It's also taking over all of the network, coming in all of the ingress and egress traffic in and out of your container, in and out of your pod, I should say. And when it does that, it also has to be very efficient. It can't add a lot of latency to it. And they've done that as well. Excellent. I'm going very quickly over the architecture of Kubernetes, and I realize that, but I just want to let you know there's some features here within Kubernetes that allow Istio to work very nicely with it, and one of them is a sidecar pattern. This bug is after me. So there's this is an example in the YAML file how 2 containers. Here's one container called I don't know if you can see my cursor. Nginx, and here's another one called, where's the other container? It is called image Debian. So there's a Debian container and an Nginx container, and they're working together as two things. So in the meshing, this would be your microservice container, and then down here would be the Istio container called Envoy that gets injected as a sidecar. And it gets injected automatically. You actually don't have to write YAML files to inject. You can, but it's not recommended. You don't have to write the YAML files to have Envoy injected next to your primary application. Okay, and on top of Kubernetes, there's a big part of Kubernetes is observability, or day two. Observability is about, there's three pillars of observability: logging, tracing, and metrics. And you can get nice dashboards with it. Since Istio and Envoy is taking over all of the traffic, by definition, it knows exactly what's going on inside your network. Therefore, it has a wealth of information. And what it does is it publishes that information to things like Prometheus and Jaeger on open tracing or logging stacks. And all of that information can go to databases, data stores, as well as dashboards. So that's built into the Istio mesh as well. So that's really high level. I'm not really doing Kubernetes justice right there, but I just want to let you know it's standing on top of that giant. So let's dive into Istio. Istio, it comes from the Greek word to sail, or the fabric sail, sailing. Kubernetes means steersman or pilot, so it's following the same marine terminology, Greek marine terminology. So Google and had this project, Borg and Omega, and they realized that meshing was missing from Kubernetes when it went open source. And they were looking at IBM, and IBM had an interesting project called Project Amalgamate. And I said, yeah, this is it. This is the meshing that we need. And what they were missing was that sidecar injector. And they realized that Lyft already had within their Kubernetes system a sidecar that was doing meshing. So the three of them got together and created this project called Istio. And then Cisco, Red Hat, and a few others have gotten involved in it as well. And there's lots of companies that are doing a lot of things with Istio. Istio had its first birthday, 1 year birthday in 2018, or now 2020. So the Istio mesh has been around a while, and there has been multiple revisions. In fact, I'm going to show you a hands-on tutorial. I just spent the last week revising my online tutorial so that you're using a more current one with the latest version of Istio. So it's changing a lot. So here's the Istio architecture. I just want to let you get understanding of how this works. There's two planes. I'm going to talk about the high-level components here. There's two planes to the Istio mesh. There's a data plane up top, and there's a control plane down below. Now the data plane is where your Envoy is. That gets injected. The control plane is the controllers for the Istio mesh. There used to be one called the Pilot, the Citadel, and another one called the Mixer. They refactored it. It's now called the Pilot, Citadel, Galley. There's a few other components in there too. And those used to be separate pods on Kubernetes. And they found actually to restructure it and put it into a single process in a single pod called Istio-D. So it's now a daemon process running in a pod in the Istio system namespace. It still has a Pilot, the Citadel, and now the Galley, but those are all buried inside of the Istio-D process inside the pod. Now you can have replicas of those, of course, but that's the control plane. So what's the Pilot? So the Pilot is it's the shepherd. Right? So if you think of all the envoys out there, all the sidecars as sheep, the Envoy is basically the shepherd that's managing the life cycle of all those sheeps. It spawns the sheeps, gives the sheep information, and then when the sheep knows to go away, it'll kill the sheep and slaughter the sheep. And it'll shear the sheep as well. Basically, all of the information about how you want to do your mesh. So you as an application developer can define YAML files and say, this is what I want to do. And Istio, the Pilot, will look at those rules and interpret those rules and sync those rules out to all of the sheep. all the envoys next to the sidecars. Okay, that's what the pilot responsibility. It's the main controller. It's following this pattern called the operator pattern on Kubernetes. It's a whole nother talk. There's this thing called the Citadel, which is basically your certificate of authority that's managing a library of all your certificates. With a flip of the switch, you can turn on mutual TLS, mutual encryption, between all service communications within your network. That's one of the great advantages of Istio Mesh, is that you don't have to do anything with Istio Mesh, with TLS. In fact, all of your when you write your code, you can just code your applications to just talk to port 80. But when you add Istio Mesh on top there, no communication will happen unless it's 443 TLS. And Istio Mesh will take care of, because it's taking over the routing table, it can then rewrite the ports to make sure that when you talk to port 80, it'll say, oh, I'll proxy that and take that and I'll write to port 443 TLS. And it will take care of creating the certificates, refreshing the certificates, and storing the library of certificates. If you want to use your own certificate manager, it actually has a plugin so you can connect to other certificate managers through the Citadel. The last one that I want to talk about is the galley. And the galley is the thing that is actually working with the pilot, and it's interpreting all your YAML files and declarations and turning those into rules. And those rules are the things that are getting sent out to the envoys, out to the sidecar. So the pilot is managing the synchronization of all that information. The galley is where the business logic is of how do you control your mesh and for policy enforcement. And we're going to get into a few of those YAML files to see what they look like. But I don't want to run out of time here because the demo is going to take a little time. So in about 10 minutes, we're going to run the demonstration if I can get through all of this theory first. So I just did a high-level view of the Istio mesh. There's more details, of course. It's a more complicated system that I'm presenting here. But I just want to let you know there's a data plane and a control plane. Yeah. Let me just talk very quickly about the data plane. Here's your envoy. Here's the sidecar injector. It's written in C++. It's a proxy. It adds less than about a millisecond of latency in a lot of different tests. So it's not adding a lot of latency to your system. And it's taking all of your inbound and outbound traffic. And it provides a wealth of business information about how all your services are communicating with each other. As well as health of your system, the health of your network. It's giving you the fallacies, the 8 fallacies of distributed computing. It's measuring those fallacies. When things go wrong, it captures that information. And it sends out to monitoring systems. So that's a high-level view of what Envoy does. It's a really interesting code, a really interesting program. To install Istio, we're going to do it in a few minutes. So I'll show you it. But it's basically saying, 3 lines of code. Here's so if you're an operations person, you need to install Istio. Or if you're experimenting on Minikube on your local laptop, you give it your Istio version, you curl this URL, and run a shell script. That shell script has the intelligence in there to download and install Istio for you on your Kubernetes. It'll recognize your Kubernetes cluster and go from there. It also provides a command line tool called Istio Coddle or Control, Istio Control. So that Istio manifest apply there's different flavors of Istio, different, like you want a large Istio, you want a small Istio, you want a demo Istio, and there's different profiles that have opinionated configurations, and they will install it for you. It uses Helm underneath. But they isolate you from the nuances of Helm and the different versions of Helm on different Kubernetes versions. I can get into the details of, I just want to let you know, there's like 4 different ways of injecting your sidecar into your business application. One is when you install your applications into a namespace, before you do that, label your namespace with Istio injected equals enabled. And that'll tell the Istio system, oh, any new pod that goes in here needs a sidecar inserted into it. And it will do it automatically at runtime. So when you add your pod, Istio will come and go, oh, okay, let me add the Envoy sidecar next to it. And it takes over all of the routing, ingress. And if your application has no idea has no concept, has no coupling to the fact that it's now working with it's not really working with a sidecar, but it has no idea that the sidecar is there taking over the inbound and outbound traffic. It's surreptitiously. So the injection can also be done at the command line. So you can say Istio control, here's my Kubernetes manifest. When you do it, look at the manifest and inject it in line. So it'll do it right in the YAML file as a sidecar injector. The other way of doing it is an annotation in your YAML files for your application. You can add a label, sorry, not a label, but an annotation saying with key and a value of true. And that will say, yeah, Istio, I have a new deployment here. Make sure you install your sidecars next to my application, please. So you're controlling it. There's 4 different ways of controlling it. And the last way to do it is you can submit a definition to Kubernetes through a config map. And in there you're saying, yes, for these namespaces, please inject the sidecars. And for these namespaces, please don't inject the sidecars. I don't want these to be part of it. So you can selectively say what's part of the mesh and what's not part of the mesh, which is very powerful. Well, with Istio version 1.0, there's about 51 CRDs. I can imagine there's more than now. I haven't done a recent count, but we're up to 146 now. So these are all the YAML files. So kind Prometheus, kind destination rule, kind virtual service, kind gateway. These are all YAML files that you as a developer can specify, which allows you to declaratively manipulate the mesh and to do interesting things with it. And I'm going to show you those examples in the demo. Some of the interesting things you can do with the mesh, now that you know that you have it installed, is you can start doing things like routing. You can do A/B testing, routing rules, load balancing, shifting, meaning I want some traffic here to go to this version of the microservice, and then when I get more confident with it with a canary, I want to shift more of my traffic to the canary because I'm gaining more confidence that the new version is working. So that's really interesting. Mirroring is I want all the traffic that goes to this microservice. I want it to go to another one too. That might be a testing one. So I'm going to route it to also a testing one. It's an interesting thing where you can split traffic to 2 different places. Lots of different things you can do with controlling where messages are sent and to what versions of your services. So it gets really interesting when you can deploy multiple versions of your service out there, and you can have multiple, or you can have different personas of people, of users using different versions of your services based upon your routing rules. I'm going to show you that too in the demo. Resilience, circuit breakers, you can do health checks, retries, these rate limiting. You can actually inject faults. So you can make a YAML file that injects a fault. It says, okay, I don't like Jason and he's going to experience a delay. Maybe Jason is a quality tester and you want to see what injecting a delay does to the quality of the system. It's kind of interesting. That's part of the chaos testing inside of Kubernetes that you can do. I just want to let you know that Istio works primarily at layer 7. If you look at the 7 layers of networking, there's another thing in Kubernetes called the network policy that's working more at the TCP layer, UDP layer. That's layer 5. But Istio, the nice thing about Istio and meshing is it's working closer to your application layer, your data plane, your data layer. So you can really make meshing manipulations next to your application, close to your data. And if without meshing, what people tend to do to simulate things like these routing rules, like to do things like these routing rules, you would have to, inside your microservices, add rules. But the nice thing is that you shouldn't have to do all these routing rules or fault injection or delays. Instead, you do it at the level 7 inside the mesh rather than inside your microservices, inside your containers. Because the last thing you want to be doing is changing your containers when you're doing all that stuff. So ingress. So here's an example of a YAML file saying I have a gateway. I want from outside access. I want to come in to the mesh, and I'm just checking the time because I want to get on to the demo. So that's an example YAML file where you can control the ingress coming into your public ingress. And that gets routed to a virtual service, and everything is connected to each other like it is in normal Kubernetes. Everything is connected to each other using labels. If this match, this label is usually selectors. See the selector? Here's a selector. And then those selectors match the URL, the labels, then there's connections that get made. So this is a way to connect the outside gateway to a service within your cluster using URLs. I'm glossing over that, I realize, because I don't want to. I'm going to run out of time here. So traffic routing, here's one way of doing it. I want the virtual service is very powerful. So when I come into my virtual service, I want all my traffic to go to version 1. Okay, that's very straightforward. But you can also do something like, well, if the user is logged in as JSON, and inside the HTTP header is a key called end user, and that end user happens to be JSON or quality tester or beta user or alpha user or whatever your business rule is, you can say that JSON will get version 2. Everybody else gets version 1. So now you can start doing selective canary deployments for a select group of users. And there's no coding. Well, there is coding. We have to create this YAML file. But it's a declarative system, and the mesh will take care of that for you, of actually implementing the rule. That's the power. So yes, adding meshing to Kubernetes adds more, it makes your life more difficult. But once you start seeing declarations like this and you just think about how would you code this otherwise, that's where you start realizing, this is why I need an Istio mesh. Okay, traffic shifting. I want 95% of my traffic go to version 1, and I want 5% to go to version 3. Just want to see what the reaction, I want to monitor version 3 before I gain confidence. And then once I've looked at the monitoring of version 3, I want to shift more of my traffic. 50% goes to version 1, 50% goes to version 3. So you can do percentages, and you can there's a couple different rules that you can do to do it. Here's another one where you can say, I want for Jason, who's my quality tester, I want Jason to experience a 7-second delay all the time when they get to either version to the version 1 of my system. So that's a way to purposely inject some testing chaos. 80% of the time, I want Jason to experience a 500 HTTP time. I don't want the service to actually work. I want the mesh to return HTTP 500 just to see what the system would do and what Jason's reaction would be when that fault is injected. So that's, again, more interesting things you can do with chaos testing with it. And with observability, you've got lots of metrics coming into Istio. I want to get into correlation IDs. There's a dashboard for Istio, so you can visually see what's going on. You can do Istio coddle commands and get introspection into your mesh, but it's also nice to have some eye candy so you can see what's going on with Istio. Observability, like I said, logging, tracing, and metrics are the 3 pillars of observability, and Istio Mesh is providing data for all these different types of observability patterns. And if you want to know more about Istio Mesh, here's a free download of a PDF from O'Reilly. It's just a call out to this one as a freebie for you. There's the URL for it. Hopefully it's all being recorded for you. And I'm trying to quickly move on to this book info. The book info application is a hello world for Kubernetes, for Istio Mesh. So what we're going to do is I'm going to show you this product page where it's like there's this book review, and there's a microservice there that we're going to do like a canary deploy. There's one microservice. There's 3 microservice versions. There's a no stars version. There's a black stars version, and there's a red stars version. It's not complicated, but it is a great demonstration of Istio. So we're going to go through the way this architecture looks. Is you have a product page written in Python. You have 3 Spring Boot applications, reviews v1, reviews v2. It's just showing the different colored stars or no stars. And you have a Ruby application that's showing details, and you have a Node application that's doing ratings. The thing to stress here is that it's polyglot, and these applications know nothing about the mesh. You, as an application developer, just write your microservices in your languages of choice, and the mesh is sitting outside of it. And what happens is the envoys get injected next to, so instead of the product page talking directly to reviews v1, when you add the mesh, the product page still thinks it's talking to reviews v1, but it's all via the proxies. The proxy takes over next to the product page, which then communicates to the proxy that's next to the v1 microservice. So that's how it's injecting itself into the mesh, and then Kiali can show you that network. All right, so we're gonna do a hands-on application, and I have a few minutes for it, and I also want to reserve a little bit of time for discussions. If this demo does not work out, you can run it yourself. And let me show you from the top. So I have these things called Katacodas. Katacodas is a wonderful system. It's now owned by O'Reilly. And I write a lot of online sessions and tutorials in Katacodas, and I present this way. It's a really nice way to present. These are all free. And if you go to my courses at katacoda.com/JavaJohn, you'll see all of my Katacodas I've written. Other people have written Katacodas as well. There's lots of Katacodas up there. If you're an O'Reilly subscriber, they have Katacodas within O'Reilly as well. I have one called under the applications course. I have one, there's Nginx. It's a great way to learn Kubernetes, but I have one called Istio Getting Started. So we're going to quickly launch that. And there's a nice welcome splash page, gives you an overview. We're going to skip that for efficiency of time. And on the left-hand side, so right now what's happening is the cluster is starting. On the right side, we have a bash terminal, and we're going to have a full Kubernetes cluster running in a second. On the left-hand side is just simply Markdown, and it's taking us through instructions. Right now we're in step 1 of 8, and I'm going to walk you through step 1, step 2, step 3, all the way up to step 8. And hopefully we're not going to run out of time here, and we'll all get to step 8. If we don't get to step 8, basically what I'm going to show you is JSON as a user and experiencing that traffic and that traffic shifting. So we have a Kubernetes cluster that's running now. It's 2 pods. It has a master called, it has a worker, master node and a worker node. Control plane is the master node. And there's actually Helm installed, and there's a Kubernetes dashboard that's installed. I'm not going to take you to that. I just want to let you know we have a Kubernetes cluster at our beck and call. If we say kubectl get pods in all namespaces, this shows us that we have basically a Kubernetes cluster up and running with a few pods. These are just the control plane elements of Kubernetes. Istio is not installed yet. Let's do that. So the next step is, okay, what Istio version do you want? I want Istio version 167, which happens to be the latest. And like I showed you in the slide, there is a simple Istio installation that they have opinionated install. And we're simply going to follow their installation rules, and it's a shell script. So right now, what it just did is it installed, it didn't install Kubernetes as a whole. It just downloaded the Kubernetes, it downloaded the Istio package, and we now have Istio control in our path, and it's right there. And the next one is the big one, which basically starts Istio operator. So there's an operator pattern in Kubernetes that allows you to, operator patterns. Operators in Kubernetes are management systems that run inside of pods that control the configuration of a larger complex system. Like you can have an operator for Kafka, or an operator for RabbitMQ, or an operator for a database, or an operator for your application. It's a really interesting pattern. So anytime you have more than a few containers and the configuration is variant across different Kubernetes clusters, what architects do is they'll put together operators. So Istio has an operator that allow you to control the mesh at a higher level. So you can control the mesh at the Istio level, but the operator is a layer above that that's controlling the installation of Kubernetes. It's controlling the installation of Istio. So what we're doing right now is we're starting that operator, and the operator in turn is starting all of the components that we wanted for this demo. And if I talk long enough, it'll be done. It's almost there. It's coming along. So that what we're going to do right after this is we're just going to verify that the components, it installs all of the components into a namespace called the Istio system namespace. That's the control plane. And it just takes a second beyond this. Let's check our time. 15 minutes, good. And so there we have Istio up and running. If we say kubectl, hey, kubectl, can you give me all the deployments in the Istio system namespace? And here are our control planes. And you should see Istio D. Remember on my slide, Istio D, inside of it had the pilot, the Citadel, and the other one. Those are all inside of Istio D. Kiali is the dashboard. There's Prometheus, which is a metrics database, time series database for our metrics. And tracing has been installed as well. And as well as an ingress and egress gateway. So these are the control planes. Oh, Grafana too, which is the dashboard. I'm going to show you some of these when we get it up and running. So we now have Istio running, and Istio basically says, yep, there's your control plane, everything, here's your versions, and everything, we're good. All right. So the next step, this step is just talking about the Istio architecture, but I already went into those in the slides, so we're going to skip over this diagram that I already showed you this diagram. Okay. So now let's getting into the hello world application. For now that we have Istio running, and it's healthy, we're going to install the book info application. Again, this is just a generic set of microservices that run on top of Kubernetes. You can run book info without Kubernetes, and it will still, you can run book info without Istio, just on regular Kubernetes, and it will still work. But we happen to have Istio installed. So what we're going to do is there's first I want to prepare, and I want to tell this Kata Kota scenario, there's a couple services here for Istio, please expose them so that we can get to them. So that's what that step did. And it basically found where the master was, and it's now injecting, allowing our Istio gateway to know where our Kubernetes cluster is. And the last, remember I talked about there's ways to inject the envoys as sidecars? I'm taking the labeling the namespace approach. So we're going to install our book info application into the default namespace. So I'm going to label the default namespace to have injection equaled enabled. And that should be enough. So now Istio knows, oh, anything new that goes into the default namespace should have the sidecar injections. All right, let's do that. So let's install the book info application. If we cd to, we're going to go into the directory of Istio. And that's just right here. And if we, there's a YAML file in there. It's a single YAML file with all the, remember all those microservices? It's a single YAML file that has everything inside of it to start book info. So rather than doing all individually or doing a Helm chart, it's just a YAML file that installs them. Boom. All right, so now they're starting up. If we say get kubectl deployment, you'll see we have the product page, and we have the ratings, the version 1, version 2, version 3, Python, Ruby, Spring Boot. These are the containers that are starting. It does take about a minute to start. So it's pod initializing now, and it'll start in a minute. And once it's running, we're going to be able to, we can get to, just prove that we can get to the application without using any kind of Istio fanciness. Right now, we're just going to run a kubectl command that proves to us that it's up and running. So it does take a little while. I don't know why. These are really, they should be very small containers, but maybe they're not really distilled down enough. But for some reason, they take a long time to download and get started, much more than they should. By the way, the second time you do something like that, they run a lot faster. Since I'm just looking, I'm seeing chat messages go by. This is great. I'm sorry, I haven't been paying attention to the questions in there. I do want to just get through the demo and then allocate some time for the chat. But now that I'm here, so we're still waiting for pod initialization to go. So let me just take a look at Jeanette asked about CRDs. It stands for custom resource definitions, and it's part of the operator pattern. So if you want to know more about that, you can search on things like Kubernetes operator pattern or Kubernetes custom resource definitions. And it's a way for you to add additional, so there's a kind deployment. You can add additional ones to Kubernetes that are your own. So kind function, if you want, or kind workflow, or kind machine learning. You can add your own resources to Kubernetes and follow the same diagram. So the containers are up and running. And right now, what I just did is I ran a container on the side that just pinged the title page, and sure enough, I'm getting a simple bookstore app. I'm going to go through the ingress gateway for Istio. There's our gateway, and we're going to ask Istio, is everything good? Can you analyze this? Yes, everything's good. So I'm just going to grab the host and the port of that external public URL. Sorry, it's not the external public URL. It's just, didn't echo it. Echo, this is within the cluster. This is within the cluster. Wait, why is that showing? That should have worked. Host. Ingress. Gateway. Okay, that's not working for some reason. I don't know why. I hope that's not the demo gods, but it's not. I don't think it's important. It was just another way of demonstrating it. What is important that we get to the product page, which I'm showing you right now. So no demo gods here. So now what's happening is the application is up and running, the book info application, and it's running, and the Istio sidecars are running next to all the containers. So I'm just going to apply some default rules to tell Istio Mesh all these things can communicate to each other. And I want to get on to, this is just a step that talks about the architecture for book info, but I already showed you that slide, so you can skip over this step. Step 7 is this is the meat of the talk, and I want to show you some an example of a routing rule. So right now, here's a routing rule. So right now, if I go to the application and I click on refresh, every time I get the page, I'm going to get red stars, or I'm going to get no stars, or I'm going to get eventually black stars. So it does kind of just a statistical round robin load balancing between the three versions. But now what I want to do is we want to add a special rule that says everybody gets version 1, which is no stars, but if you're JSON, you get red stars. So let's apply that rule, single line, single command, apply the rule. There's the kind. So this, to answer your question about custom resource definitions, Istio added a CRD, a custom resource definition called virtual service, kind virtual service. That's not part of generic Kubernetes. When you add Istio, which is an operator, it adds these CRDs, and the virtual service is a custom resource definition called virtual service, which allows you to send in this YAML file for declarations to control the Istio mesh. So now that we have that in there, we can hit refresh again, and we'll see that we're just regular users. So the only thing we're getting is no stars, which is version 1 of the microservice. But if I log in as JSON, right? I get the version 2. I get version 2, yeah, not version 3. I get version 2, which is the black stars. No stars, black stars. So I'm testing out with Jason the idea of having stars for the book reviews. Very typical business application, business scenario that you want to do as a developer. You want to test out what the reaction is from your users, because your users are the most important people in terms of understanding what the business requirements are. So the other thing you can do is you can do start traffic shaping. So let's look at this rule. Taking a while. My CCAT thing is, it's just an alias. So I'm just going to, and it's a little runs a container that does colorization. So there's our, I just did cat. So what this rule does is I want, no matter who it is, whether it's Jason or not, I want 50% of the time to go to no stars, 50% of the time to go to red stars. So if we apply that and quickly go over, see how fast it gets applied? So now, whether I'm Jason or not, we're getting no stars and red stars. So version 1, version 3. And it's just randomly, if I sign out as Jason, it's the same. If I get no stars. So the other rule that was in there is gone. Now this rule is in here as only. Okay. See how that works? You have a lot of control over it. By the way, you can run this code yourself. It's free. There's no credit card. There's no email sign up or anything like that. Just go to this URL and you should be able to run it and share it with your colleagues as well. I could do another one. Here's another review of this. So, okay, now that I really like the red stars, I want to shift all of my traffic to version 3. That's just, and you can just apply that. And now every time you go to the bookstore, you're only going to get the red stars. And notice how it happens. It's right away. It's instantaneous. That rules gets sent out. Yeah, there's more things you can do. The Istio control is has a lot of nice access to it. One of the things that is nice that you can see is, okay, I'm going to show you just a little bit of eye candy, and then I'm going to go on to questions. So here's your dashboard that Istio also sets up for you. So if we wanted to see our Istio control plane, they have opinionated dashboards for that. Voila, okay. You can see traffic coming in and out of the application. These are real-time graphs. The other one you can look at is Kiali, and the login for this is admin, and you can filter on the namespace. I forget where the app graph default namespace. It should, yeah. So there's our application. It goes into the product page, and the product page goes to reviews. And there's interactive drill down. You can get into all of the different aspects of Kiali to be able to introspect your mesh. So I'm out of time here, but I have like a minute left, so I want to see if I can look at a question here. Can I have a single mesh in my apps that are deployed across multiple cloud vendors? That's really talking about a single mesh in my apps. Yes, well, the idea behind meshing between the YAML files and the manifests is that you should be able to deploy this across. They're not tied to a single cloud vendor. So say you have it running a Minikube and you have a bunch of YAML files that define your mesh. You can then take your whole application that's running a Minikube and run it on EKS, Amazon Kubernetes, and those same YAML files will get applied. They have no context, very little context about the outside world. There's a little bit of context, but those are handled through the YAML files, and Helm charts help you to do that. So yes, you can deploy. The idea is to have a single set of code that you can deploy to a lot of different environments. Needed help with Istio upgrade. I have a customer. Yeah, it's upgrading is hard. I can't answer that question in the little time I have. but that's part of the difficulties of Istio, is that there's a lot of moving parts and there's a lot of installation choices to go between them. Since the previous one customized, how can I upgrade to 1.6? I'm not understanding, Vanath, I'm not quite understanding it. How can I upgrade to 1.6 version with Canary upgrade? Do you mean Canary upgrade of Istio, or do you mean a Canary upgrade of your containers? I think I showed you a Canary deployment using YAML files. Yeah, the previous version was 1.5. How are the upgrades to the Envoy sidecar handled? Can they be handled without involving changes to the Yes, upgrades. So upgrades to the mesh, one of the ideas of the Istio operator is it should also be able to handle upgrades from version to the next. How well it does it, there's always those nuances of software.